Hello students, today we will study about types of matrices and also operation on matrices. So, to begin with, what is a column matrix? A matrix is said to be a column matrix if it has only one column. For example, 1, -2, 5, 6, 2. Now, what is a row matrix? A matrix is said to be a row matrix if it has only one row. For example, 2, 4, -1, 0, 6. What is a square matrix? A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. Thus, a m by n matrix is said to be a square matrix if m is equal to n and is known as a square matrix of order n. For example, 2, 3, -1, 4, 1, 6, 0, 3, -1, 2, 1, 4, 1 are two square matrices of order 2 by 2 and 3 by 3. What is a diagonal matrix? A square matrix whose all the elements except the diagonal elements are 0 is called a diagonal matrix. For example, 5, 0, 0 minus 7, 2, 0, 0, 0, 5, 0, 0, 0 minus 3. We also define it as a square matrix A as Aij is called a diagonal matrix if Aij is equal to 0 for I not equal to j and Aij not equal to 0. Now, what is a scalar matrix? A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That is, a square matrix A is a scalar matrix if Aij is equal to 0 for I not equal to j and Aij is equal to k. For I is equal to j, k is a scalar. For example, A is equal to 3, B is equal to -1, 0, 0 minus 1 and C is equal to √3, 0, 0, 0, √3, 0, 0, 0, √3. They are scalar matrices of order 1, 2 and 3 respectively. Now, what is an identity matrix? A square matrix in which elements in the diagonal are all 1 and rest all the elements are 0 is called an identity matrix. In other words, the square matrix A is an identity matrix if Aij is equal to 1, if I is equal to j and 0 if I is not equal to j. For example, 1, 1 0, 0 1, 1 0 0, 0 1 0, 0 0 1 are identity matrices of order 1, 2 and 3 respectively. So, we observe that a scalar matrix is an identity matrix when k is equal to 1, but every identity matrix is clearly a scalar matrix. Now, what is a zero matrix or a null matrix? A matrix whose all the elements are 0 is known as zero matrix. It is denoted by O. For example, 0 0 0, 0 0 0, they are 0 elements in 2 rows is a zero matrix. Similarly, 0 0 0 0 is a square matrix having 0 of order 2. Students, it is very interesting to note that a scalar matrix is a diagonal matrix, but a diagonal matrix may or may not be a scalar matrix. Now, what do you mean by equality of matrices? Two matrices A and B are said to be equal if they are of the same order, and secondly, each element of A is equal to the corresponding element of B. For example, 2 3 0 1 and 2 3 0 1 are equal matrices, but 3 2 0 1 and 2 3 0 1 are not equal matrices. Symbolically, if two matrices A and B are equal, we write as A is equal to B. Let us take one example here. If 4 3 x 5 is equal to y z 1 5, find the values of x, y and z. Here you can observe that the corresponding element to x is 1. So, the value of x is 1. Similarly, the value of z is 3 and y is 4. One more interesting example here. Find the values of x, y and z if x plus y 2, 5 plus z x y is equal to 6 2 5 8. On comparing corresponding elements, we get x plus y is equal to 6 as first equation, 5 plus z is equal to 5 as second equation, and x into y is equal to 8 is another relation here. Therefore, from first equation we get y is equal to 6 minus x. From the second equation, the value of z is 0. Substituting y is equal to 6 minus x in first equation, we get x into 6 minus x is equal to 8. That gives a quadratic 6 into x minus x square minus 8 is equal to 0. Arranging in standard form, x square minus 6 x plus 8 is equal to 0. Now, by splitting of middle term, we have two factors, namely x minus 4 and x minus 2 is equal to 0, which on simplification gives x is equal to either 4 or 2, and corresponding values of y will be 6 minus 4 2 and 6 minus 2 4. Therefore, the values of x, y and z will be x is equal to 4, y is equal to 2, z is equal to 0 and x is equal to 2, y is equal to 4 and z is equal to 0. Now, let us discuss about some operations on matrices. In this section, we shall learn about addition of matrices, multiplication of a matrix by a scalar, difference and multiplication of matrices. To start with, addition of matrices. Addition of matrices is defined if matrices are of the same order whose each element is obtained by adding the corresponding elements of two matrices. Now, to understand the operation of addition on matrices, let us take up one example. Let A be 2 4 3 2 and B matrix be 1 3 minus 2 5. Find A plus B and A minus B. For the solution A plus B, we know we will be adding corresponding elements of the two matrices 2 4 3 2 plus 1 3 minus 2 5. So, adding 2 plus 1 gives me 3 as the first element, 4 plus 3 as the second element of first row. Similarly, 3 plus minus 2, that gives me 1 and 2 plus 5 is 7. So, A plus B is 3 7 1 7. Now, to see the subtraction of matrices A minus B, we can write 2 4 3 2 minus 1 3 minus 2 5. Subtraction means adding negative of a matrix, that is 2 4 3 2 plus minus 1 minus 3 2 minus 5. Now, 2 minus 1 gives me 1, 4 minus 3 gives us 1, 3 plus 2 5, 2 minus 5 is minus 3. Now, multiplication of a matrix by a scalar. Multiplication of a matrix by a scalar k is a matrix of the same order whose each element is obtained by multiplying corresponding element of a given matrix by scalar k, that is k into A is equal to k multiplied by the matrix A I j of order m by n, that is obtained by multiplying every element of the matrix by k of order m by n. Now, what is negative of a matrix? The negative of a matrix is denoted by minus A, and we define minus A as minus 1 into A. For example, A is equal to 3 1 minus 5 x, then minus A is given by minus A is equal to minus 1 into A, that is minus 1 into 3 1 minus 5 x. So, every element is multiplied by minus 1 and we get minus 3 minus 1 5 minus x. Now, to understand the meaning of difference of matrices, if A and B are two matrices of the same order, say m by n, then difference A minus B is defined as a matrix D, where D is obtained by subtracting B from A, that is D I j is equal to A I j minus B I j for all the values of I and j. In other words, D is equal to A minus B, that is equal to A plus minus 1 into B, that is sum of the matrix A and the matrix minus B. So, students, today we discussed about different types of matrices, operation of matrices, that is addition and multiplying a matrices by a scalar, negative of a matrix and difference of matrices. In the next session, we will take up properties of matrix addition and multiplication of matrices. Thank you.